have ridden a bike before at some point in your life, but have you ever really stopped to think about what exactly you were pedaling against? Is it the weight of your bike and you on it, or is it the inertia created by the cranks, or maybe something else? Well, I bet you never really thought that it was actually just the air around you that created the most forces against your motion. And pretty much the fact is that aerodynamic drag dramatically impedes the performance of competitive cyclists. Now, I'm a competitive cyclist myself through the sport of triathlons, and sorry for my lack of clothing, but so this is something that really affects me and is really a big concern to me, and I've done a lot of research on it in the past. And of course, it also concerns people like Lance Armstrong. So today we're going to take a look at what forces really impact you as a cyclist, how aerodynamic drag measures up to those, what causes aerodynamic drag, and also putting a little bit of numbers to the madness to see how much time someone can actually save by reducing drag. So pretty much aerodynamic drag is the largest force a rider must face during a race, but what exactly does that mean? Pretty much some of the forces that are against you whenever you're riding are the force of rolling associated with your tires, the force associated with gravity and the slope of the hill you're going up, the force due to your acceleration of speeding up and getting into your pace, and also the force of air drag. Now, in a time trial or triathlon situation, which is non-draft legal, typically your courses are relatively flat, so the force due to slope is pretty negligible. And also, once you get up to speed, you pretty much stay at consistent speed throughout the race. I mean, that's part of what pacing is. So those two forces essentially are pretty negligible over the time period. So taking those into account, here's a graph displaying the force of rolling versus velocity, and also the force of air drag. And as you can see, once you get up into the race pace speeds up to about 40 kilometers per hour or so, pretty much the air drag is the primary force that's impeding your motion, because rolling speed pretty much only depends on how much you weigh, and that doesn't change with how fast you go. But air drag does depend on your speed. It actually depends on the square of your speed. So the faster you go, the harder and harder it is to go faster. So what exactly creates this drag? Well, the primary cause of the drag is actually the rider. It composes about 75% of all the drag forces that are associated with a cyclist. Because, I mean, if you think about it, you're like this big blob, of surface area, trying to pass through a fluid at a high speed, and of course it creates a lot of drag. And there are two main components of the drag force. One being the friction force of the air hitting you and splitting off, and also another force created by the low pressure system behind the rider. Now, it works a lot like the same way as lift does when associated with the airplane wings. I mean, we all know that the low pressure system goes over top with the high pressure system on the bottom, and it creates lift. It's the same kind of principle, except for the low pressure system is created behind the rider, which actually pulls them backwards. So even though the rider is the main contributor to this force, on the right you can see a diagram of a cylinder, like a water bottle or maybe a seat tube or some other component of a bicycle that creates the same effect on a slightly smaller scale. So, So how much of an impact can this actually have on a rider? Well, I got this data from Fitworks, which is a website that specializes in triathlon cycling and cycling in general, and also Triathlete Magazine concurred with this evidence. It said the average triathletes experience about 7 pounds of drag force against them during a race. Now, if you kept a constant power with that over a distance of 100 miles, which is slightly less than the Ironman distance of cycling, at 20 miles per hour, it would take you about 5 hours to complete the race. However, if you reduce your drag by just 10%, or about 0.7 pounds, and kept the same distance and the same power, your speed would go up to 21.4 miles per hour and would save you up to 21 minutes in time, which is pretty significant, a drop in time. So pretty much we've covered what exact forces are dealt with cyclists, how they are caused, and also what kind of impact they can have on them. And I'm sure if we apply the same kind of principles to this problem that we do with, say, heart valves and driving cars and stuff like that, we can come up with a pretty simple solution to reduce air drag.